Hi everyone. So now we study our implementation of GAMS, generalized additive models. So GAMS. So first we want to use the two libraries. So one library is ISLR. This is for data, wage data. And another library is for GAM function. So you can install the function if you have not. So we use GAM function. Yeah, so remember that we are using wage data. So wage data is this data. So we compare the wage of workers by several factors: the year recorded and age of workers and some other marital status and race and so on, and educational level and so on. And we are using this year and age and education to explain wage. So at first attach wage, and since this year is discrete variable, this is not optimal for scatter plot. So this time I try to define some noise on year. So we can use the jitter function. So this is useful to make a scatter plot for some categorical variables. So this add noise for illustration purpose. So now we think about, we generate pairwise scatter plot of wage and age and year with some noise and education. Then we can get this figure. So you can see that wage and age has some complicated relationship. In the middle, we have higher wage. In the middle age, we have higher wage, but the lower age and higher age, we have the lower age, lower wage. Yeah, so we have the also compared the year with wage. Yeah, so actually the year is recorded from 2003 to 2009. So actually this should be only, it can take only 7 values, but we add some noise so that the how many observations for each year. So actually we have almost the same number of observations for each year. So we cannot really see the meaningful graph. But for example, if we have fewer observations in 2003, then we have the more sparse the graph in 2003 here. So year and wage, now it's not clear here, but actually we have already seen in the previous video that the later year we have higher wage. And education, we have level 1 to level 5. Level 1 is less than high school degree, 5 more than college degree. So we have some tendency here. So this is the data set. So now that we want to fit the GAMs. So one way to fit the GAM is use just linear model. We fit wage on year. We think about regression spline of year with degree 4 and the regression spline of age with degree 5. And education. Education is categorical variable, so it doesn't make any sense to include higher order terms. So education. So this simply fit linear model with many coefficients. So this is degree 4 polynomial of year and the degree 5 polynomial of age. Yeah, for example, we can compare this model with another model. For example, that we want to see if the fourth degree polynomial is really necessary or second degree polynomial is enough. Then we can run ANOVA, smaller model first in ANOVA function, and the GAM LM1. Then you can see that actually not significant difference in model performance, even if we add the two more terms, the cubic and the quartic terms of year. So probably that this GAM LM1 is redundant model and GAM LM2 is enough. You can also see AIC value of two models. Then you can actually see that the LM2 has lower, that is better AIC than model 1. So the two terms, third and fourth terms are redundant, you can see. So another way to fit regression spline, so these are regression splines, is using GAM function in GAM package. So GAM 2R. So GAM function and wage, and we use NS here and 2 and NS age. This time we change it into 3 degree polynomial. Education. Yeah, so now we fit the model, actually the same as the GAM LM1 model, by this GAM function. So basically we have the same result in this GAM function. So this time we get the summary of this GAM function. So you can see the basically ANOVA table. So this ANOVA table means that compared with the model with only constant, the second degree polynomial of year is significant with p-value with the 7 times the 10 to the power negative 5, so almost 0, so it's very small. And in addition to year, third degree polynomial of age is also significant with p-value almost 0. So this has 3 parameters, so degrees of freedom is 3. And in addition, if we add education, then it has additional information to explain wage. It has degree 4, because degrees of freedom 4, because we have 5 levels in education, and that means the baseline plus the 4 factor variables. And this is also significant. So you can see the usual ANOVA table here. So now we want to see the graph of f1 of x1, so the function of year and the function of age and function of education. So we want to see 3 graphs at the same time, so we type the parameter mf row, so multiple figure by row is equal to C13, so that we have the 3 graphs, the 1 row, the 3 columns. And now that we plot GAM to our SE true. This SE option that makes the basically the confidence band for these curves. then you can see these graphs. So you have seen this in the previous video, and you can estimate these ones. Yeah, so we have not linear but more complicated curve. So yes, so actually, so the wage is estimated as this function plus this function plus this function. Okay, so this is how to use the GAM function for regression splines. Okay, so next, in the next video, we will discuss the smoothing spline. Okay, see you then.